In this video, we're going to be talking about the pH scale and its related pOH scale. These are scales that we use to measure the acidity or basicity of different aqueous solutions. So one thing that we should keep in mind is that, as I told you in an earlier video, all aqueous solutions will have both H3O plus and OH minus. This is because the water molecule reacts with itself to form these things, so they're always going to be present in some amount. A solution is acidic if it has more H3O plus. The solution is basic if it has more hydroxide. If the solution is neutral, that means it has the same amount of both ions. I know we previously used the pH scale to determine neutrality. Below 7 is acidic, above 7 is basic, equal to 7 is neutral. That's true at 25 degrees Celsius, but if you change the temperature, that actually no longer holds. But concentrations are always a way to tell whether a solution is acidic or basic. So again, the way that we measure the acidity is we measure the concentration of each ion. So we measure acidity by taking the concentration of H3O+. Now, 2.37 molar acetic acid is equally as acidic as 0.1 molar hydrochloric acid. Right? Acetic acid, remember, is a weak acid, so it doesn't break up completely, whereas HCl is a strong acid, and it does. So what that means is that in a 0.1 molar HCl solution, you'll have an equal amount of H3O plus ions that you would get from a 2.37 molar acetic acid solution. Now, this is all well and good, but as you can see, these numbers are kind of a little bit unwieldy to work with, especially when we start talking about concentrations that are like 10 to the minus 7th, 10 to the minus 8th molar. What we want is we want a scale that's easy for people to understand. And what we came up with is the pH scale. The pH scale is based on a 0 to 14 scale for the most common concentrations we work with. You can actually go below 0 and you can go above 14 if you need to. And the idea is the lower the pH, the more acidic the solution. A purely neutral solution has a pH of 7 at 25 degrees and a concentration of H3O plus of 10 to the minus 7th molar. So the lower the pH, the more H3O plus is in the solution. The formula that we use to determine pH is that the pH of the solution is the negative logarithm of the H3O plus concentration. So if we take, for example, coffee. Coffee has an H3O plus concentration of 10 to the minus 5th. The negative log of 10 to the minus 5th is 5. So coffee has a pH of about 5. Now, for every factor of 10 that you increase the concentration of H3O plus, the pH goes down by 1 unit. So something that has a pH of 4 has 10 times as much H3O plus as coffee does. Something that has a pH of 2, since it's 3 units difference, has 1,000 times more H3O plus than coffee does. And keep in mind again that at 25 degrees, a neutral pH is 7. That does change, though, as temperature changes. Now, in addition to the pH scale, we also have the pOH scale. The pOH scale works very similar to pH, but it's for bases. The formula is almost exactly the same as the pH formula, except we replace H3O plus with OH minus. So pOH is negative log of the hydroxide concentration. So that means the more basic the solution is, the lower the pOH is. And we can relate pH to pOH because they will always add up to 14. So pH plus pOH equals 14. So if I give you the pOH of a solution, you can find its pH very easily. And one other thing that we can do, which is kind of relevant, is if we give you pH or pOH, you can work your way back to the actual concentrations. All you have to do is undo the logarithm. The way that you undo what's called a base 10 logarithm is you do 10 raised to the negative pH or negative pOH, depending on which ion you're working with. Something to keep in mind is that if you multiply the two concentrations, you get 1 times 10 to the minus 14th. So what this means is we can kind of work out a little box conversion here. If I put pH, pOH, H3O plus, and OH minus in a box on each corner, we can just write the conversions between them based on which way we want to go. So going from H3O plus to pH, I just take the negative log. If I want to go from pH to H3O plus, I do 10 raised to the negative pH. I can do the same thing on the other side for pOH with hydroxide. I can say pH plus pOH equals 14. And I can also say that H3O plus times OH minus equals 10 to the minus 14. Now, don't worry if this doesn't make a lot of sense right away. We're going to do plenty of practice problems with it, and we'll go through how all the conversions work, and it will make perfect sense once you get a chance to go through this.